What's up people, welcome to my tutorial in pragmatic data science. So in the previous video we did some visual analysis in Gephi based on similarity measurements that we had created previously. So I think it's easy to forget that all this is based under the assumption that our similarity measurement is actually, good. It's not going to be any better than the similarity measurements that we were able to create. And the interesting part here is that it's still accurate. It's in the sense that it's going to find duplicates, for example, but the question more becomes like the similarity measurements that we use or the rating for the graph, does that make sense? Like, will that illustrate what we are looking for within the data? And in this case I would say probably not. It's not that great. I mean, maybe if you do some deeper analysis on it, you will be able to find some sense in why it's creating these similarities. So instead, what we want to do is we want to backtrack here a little bit to the previous video. If you remember, I mentioned that we used the Jacquard similarity here. So what I want to do instead is I want to switch this out to this other implementation here, and I'm just going to fire this up because this will probably take a little while. I'm not sure if I will be able to so it's calculating the similarity here with this Rushika, or however that is pronounced, similarity instead. So what this does basically, it's a little bit different. So let's have a look at the implementation of this, also from, I think it's also from Wikipedia. Because I think it's called weighted Jacquard or something. Yeah, here it is. So what you're gonna do here instead is, let's say that, because the regular Jacquard similarity that we have here is pretty dumb in the sense that it's not weighted. It's not gonna show you how frequent the word is within the document. It's only going to say, like, is it in this document and is it in this document. It's not going to weight in any way how often it occurs in any of the documents. And that's basically a problem because it's kind of a rough estimate in similarity measurement wise. So this weighted Jacquard similarity and distance here is a little bit better in that sense. So what we have here instead is you're going to take, you're going to sum up in the denominator here. You're gonna take the minimum of the term frequency in document in the document I, and then you're gonna do the same thing for document J, and then you're gonna take the min of that. And you're going to do that for all of the terms that you have in the union of these documents. It's basically the ones that they have in common. And then you're going to sum these up, so you get the minimum of these. And then in the denominator, you're going to do the same thing, but with max instead. So you're going to take, for each term, you're going to take the maximum of it, and then you're going to take the min over the max. So take a little, I'm not sure I explained it particularly good, but take a moment to reflect on what this means. So we'll try and make more sense of this. All right, so what's it going to do here? It's just going to grab all the words from the two documents and create a union. So that's what the first line here is. We're going to have a numerator and then the denominator. And then for each term that we have in these documents, it's going to create xi and ji. Then because it can be, it's going to set the default value to 0, because remember like the key here is coming from the union, so it might be the case that it actually doesn't exist in one of the documents. So that's going to be true for some of the keys here. So but if it do exist, we grab the weight of it, and in this case we're going to use the TF-IDF as the weight. You can use any other metrics that you have aggregated previously in any other case, but here we're going to use the TF-IDF. So you're going to do that, and then the same thing it's true of course for the J document here. It might not exist because of the unions. You need to check that first. Should it be the case that it doesn't exist, you just like initialize it to 0. Well, otherwise you grab it from the TF-IDF score of that document. And here comes the interesting part. So in the denominator you do the sum. You should sum them up. So you do plus equals here, and then you take the minimum of the xi and ji, and in the denominator you take the maximum of the xi and ji. Here I call it j, but they call it y here. But you can think of the y document here as the myj document in the implementation. So then you just take the denominator over the numerator over the denominator. All right, so I've created the similarities in the different metrics. It's a little bit more complex. I'm sure there's more calculating effective implementations of these, but it doesn't really matter for our case. So I have a different similarity matrix here at this point. I need to recalculate the edge file also. So let's do that. And there we go. But now if we take a look at this, it's it only has 3 entries here, and the reason for that is probably because we have too high of a threshold here. So I think we need to lower the threshold quite a bit. Let's test it with the 0.1 instead, because remember, these are not like on the same scale. These are 2 different algorithms. You need to adapt to that. All right, so how many edges do we have here? Around 700, maybe even a little bit less. Let's give it 0.505. Maybe that was too low. Let's see. Yeah, that seems a bit too low. All of this is a little bit of trial and error here. I have to test it out until it seems to make sense. Okay, so this seems reasonable. Not too many duplicates here. And how many rows do we have? Around 5,000 edges. So that should be doable in Gephi. All right, so let's load it up and see if it makes more sense. Import spreadsheet. This is the same thing as in the previous video. So if you're confused about this, backtrack and see what I did in the previous video. Make sure this is imported correctly here. It's an edge table. Click finish. Here, don't forget this append to existing workspace and set it to undirected and load it up. It's going to do a little bit of loading here. Did it work? I'm not sure. It doesn't seem to work. I mean, this is what I mean. Like, you have to work with it and not against it. Create a new workspace here. Okay, it's not working. Okay, let's try it again. Maybe it's good that this happens so I can show you how to do it. Append to existing workspace, undirected. All right, so now it seems to be loading the edges correctly here. Let's take a look at the overview. It kind of looks the same, but that's only because we have the same amount of edges. The density of the graph is too high, so then we can actually stop this. Then we can pull in some filtering here. Let's do the edge weight and pull the filter up a bit here, see what happens. Maybe a bit too much. I don't know, maybe like this. Let's test it out. Yep, that seems reasonable. Let's also put some, if this is closed, you open it up like this. And then we're going to do nodes and edges labels. This is the same thing as in the previous video, so you can just backtrack that if you're confused of what I'm doing here. All right, so let's see what's going on here. If you want to, you can just rerun this, and it's gonna. If you think it's too dense, you can increase it like this. Oops, you can give it like another 0 here on the optimal distance, so it's gonna be a bit wider. So it's gonna be more readable, maybe. Not sure. I think it was maybe a bit too much. Maybe 500 is good. No, I don't think so. Maybe 100. I think it actually was kind of good at 10. Yeah, let's do this. I think you're gonna need a little bit bigger labels here and here. All right, so let's see if we can make sense of this. But I think I need to pull up this a little bit more, just illustrate. So here, for example, you can see that it's more accurate because these are obviously two Christmas songs. Christmas Without Daddy and Christmas Just Ain't About Without Love or something. So it's doing something here. And I don't actually know all the lyrics for all of these. So it's kind of hard to figure out what's going on here. But and also you can see here is like these are like love songs or something where people get dumped. So that's also kind of funny in a sad way. Credit card baby. If I didn't know, okay, so someone is bitter about their relationship here. Let's pull it a little bit more weight. No. A little bit less threshold then. Maybe like this. So you can like play around with this and see if you can find better like similarity measurements, and eventually you end up with something that makes sense, I think. It's a bit hard because it's not really deterministic also, but you get different clusters here. Okay, what's going on here? Okay, so these are these are Christmas songs, and I don't know, George Michael, I don't know. Maybe it's a bit speculative at this point. It's really hard to say sometimes. Maybe I should use a better data set for this. Together Forever. Did I actually save it? Yeah, I did. Did I do the similarity correct? Yeah, I did. All right, I guess it's fine then. Here's something with beauty. Still beautiful. What is this? I can see something also with beauty. So something with beauty is going on here. So you can see you get a little bit of structure in here, but this is how you would get data like in the real world. You wouldn't get it like as clear cut as you would in like any tutorial. So it's kind of like you have to dive into this and make sure that you make something that is data driven rather than just speculative. So I think that's all for this tutorial, and here's some love songs also. And for some reason the theme for this 0070, I don't know, really funny. I hope you guys enjoyed this tutorial. I think I'm gonna continue with this because this was kind of cool, I think. And I will see you in the next videos. Don't forget to subscribe and download this dataset to see if you can find any cool stuff in here. Try out like different similarity measurements, because I think you can do even better if you find a good similarity measurement. Maybe you can use cosine similarity for it, and maybe latent space, like with a single value decomposition or something, or like a PCA or something like that. That would be really cool to see. So so let me know if you have any cool implementations on this, and I will definitely check it out. So I hope you guys enjoy this, and this is actually the last video for this for TF-IDF series, and I will continue with other stuff in the coming videos. All right, don't forget to subscribe. See you later. Bye bye.